last ones, well, I'm going to talk about some artistic and literary ones, but this one was a really neat one. So this one was called Trident Terminal. Is anybody here from that team? Oh, hi. Okay. So this is a small group from various schools in Washington State, and their idea was really based on this idea of a Konechny space station, which I had never heard of before, and I ended up going down a rabbit hole of research once I read this submission. And the basic idea is artificial gravity without rotating. And the way that this is done is, this is sort of, I tried to figure out, I can't go through the whole derivation. They did a derivation in their paper of why this works. It was really cool. They had the justify your math step, and this is the math on this side, and this is the why I can make this step on this side, like a full-on proof. But the idea is that these two stations are at different altitudes, and they're connected by a tether. And the tether is attempting to keep their angular velocity the same. And the result is that they're pulling away from each other as they spin, and that pulling, the tension in the tether causes the artificial gravity. And the way that works is for the top station. For the top station, you can see they're upside down. And the bottom station, they're oriented normal. So that's because the tether is pulling this way, and here the tether is pulling that way. So that's the floor. And one of the reasons why that is an interesting idea is that there are all kinds of issues with artificial gravity. Okay. And the fact is that we know basically the main problem is that humans get sick when they spin too fast. So this chart here was not actually from their paper, but it sort of explains why they went this route. So the idea is you need to make things very large and spin them very slow in order to get humans to be able to be on there comfortable. And that is what drives the size of these colonies to be so large. It's one of the main reasons why they're so large. So if you can avoid this, the rotation, and be able to create G's, and they're not creating very large G's, I think it was like 0.2 on the top and the bottom or something. That's a potential game changer. So anyways, I just wanted to make you guys aware of it because I thought it was really cool. And so for their colony, they chose basically around Neptune with the idea that they would get water resources from Trident. And it was planned as, they call it a terminal because it's sort of like an outpost for people traveling beyond Neptune and the solar system. A couple other good things in here. They talked about a closed loop system for their life support systems. And this is a picture of NASA's risk matrix, which is just something that I think that everybody should always look at when they're preparing something like this. And the idea is your risk is a combination of likelihood and consequence. So likelihood being the probability that something will happen, consequence being, how bad is it? For instance, the likelihood that you'll get punctured by a micrometeoroid, and but is that going to be catastrophic for the whole station, or is it can it be isolated? And the idea of the risk matrix is you go through these lists of risks, and then you see where they are. Anything that's in the red area is problematic. You got to fix that. And so you would then create a mitigation strategy, and then move your items from high risk to lower. Anyways, I'm going to try to speed up because I'm running long. Of course, we have artistic merit category, and our number one